You may be wondering why you're learning about trigonometry when everything that you've learned so far in Math AS regarded functions. The thing is that you can think of the trigonometric relationships, the sine, the cosine, and the tangent, as functions, right? If you look at this would be the shape of a sine function. What does this have to do with everything that you've learned? Look at this. On the x-axis, you have all possible angles. I put on top in degrees and in bottom in radians, all right? And then on the y-axis, you have all the possible values for the sine, which you already know can vary between -1, let me put here the trigonometric circle, can vary between -1 and 1, okay? And for each angle that you have in the x-axis, you have the corresponding value of the sine on the y-axis. And as you can see, eventually it starts repeating itself. You have a full circle that goes from, for example, from 0 degrees to 2 pi, or from 0 degrees to 360. And here you have all the possible values for the sine. It starts at, let me take this out of here, at 0, at 90 degrees, at pi over 2 is 1, at pi or 180 degrees is 0 again. Let me make this bigger. At 3 pi over 2 or 270 degrees is -1. At 360 degrees or 2 pi is 0. Again, all of this comes from the trigonometric circle, all right? 0, 1, 0, -1, 0. 0, 1, 0, -1, 0. See? And then starts repeating itself. If you start adding full circles, the values of the sine start repeating themselves, right? If you go to the negative side, subtracting angles, the same thing. So this is the shape of the sine function. Let's look at two specific segments. This is the repeated segment, okay? This is a full circle that you start repeating itself. This segment is another one, the second circle, so to speak, then the third. This is to the negative side. But then you have one important part, which is this one represented here in orange. These are the principal values for the sine function. What are these? If you are given a particular value of the sine, and if you use the calculator to figure out by using the inverse function what the angle is, the calculator is always going to give you values that are comprehended for the sine between -pi over 2 and pi over 2, or -90 degrees to 90 degrees, depending how your calculator is set up. But this doesn't mean that this is the angle that you want. Let's say, for example, that the angle that you want is, that you have, for example, the sine of the angle as being 1, all right? If you do sine -1 of 1, if you have your calculator in radians, the result is going to be pi over 2. But for a particular question, might as well be over here. So 2 pi, 5 pi over 2, okay? Could be this value over here. But the calculator only gives you this. This is going to be important later on in next lesson when we deal with trigonometric functions, trigonometric equations, okay? You will need to understand that the values that the calculator give you are just these, and each one of the other two trigonometric functions will have their own principal values, and you have to use this knowledge to try to figure out other possible angles that are not contemplated on the answers that the calculator is giving you. But more on that on next lesson. I'm just going to go over the graph of the function for the other two, for the cosine. So the cosine changes from 1 for 0 degrees. When it is 90 degrees is 0. When it is 180 degrees is -1. When it is 270 degrees is again 0. And at 360 degrees, it's 1 again. All right, as you know, 1, 0, -1, 0, 1, and then starts repeating itself. Okay, so this is the repeated segment. And the principal values for the cosine function vary between 0 and 180 degrees. I didn't mention this before, but this is the shortest segment possible on which all possible values for the cosine or the sine or the tangent can be represented. All right. In the case of the sine, it varies between minus 90 and 90, or minus pi over 2 and pi over 2. For the cosine, the calculator will just show you values in between 0 and 180 degrees, or 0 and pi. And everything that I mentioned before is still valid over here. For the tangent, it's a weirder function, okay? If you look at the trigonometric circle, you understand why. It changes from 0 when the angle is 0 to infinite, and 0 to minus infinite, all right? And then it starts repeating itself every half a turn, okay? So that's why if it tends to infinite, it doesn't actually reach it. So these dotted lines, they are asymptotes where the function tends to, okay? And then again, here the principal values and the repeated segment is the same, okay? All of these are just repetitions. This is what I mentioned before. I want you to pay attention to another thing, particularly the relationship in terms of graphs, in terms of functions between the sine and the cosine. The shape of the function is exactly the same in the sine and the cosine. And if you look at it, it seems that the cosine is the sine function pushed a little bit to the left. And actually it is. And this is, but you can basically transform the sine into a cosine by using a transformation that you've learned before, okay? The cosine function is just a sine function plus pi over 2 or 90 degrees, okay? This is moved. This one is moved to the left. So you have to add the segment that by which is being moved to the left, which is pi over 2. If you want to start from this and go over there, then you have to move it now to the right. So you have to subtract the same amount. Okay? And this leads us to transformations. What you need to know about trigonometric transformations? Nothing more that you learned before. Okay? Everything that you learned about transformations in functions is the same over here. And why is this particularly important in trigonometry? Because you have well-defined functions that can be transformed into something else. This function over here can be constructed, and there are some questions in which you have to do this, or identify what the changes are from the sine function itself, okay? So in this case, is multiplied, you have a it expanded by 3 in the vertical axis, you have a compression with a scale factor of 1 over 2, and the whole thing is pushed up by 4. Here the color scheme will show you how this works.